Thank you. We're doing we did 2 number 1s. This is the third problem. It's number 2, but here we go. A 2,450 kilogram test rocket is launched vertically from the launch pad. Its fuel provides a thrust force such that its vertical velocity as a function of time is given by, okay, so what do we know? We know mass is equal to 2,450 kgs. And we know that V of t equals AT plus BT squared, where A and B are constants and time is measured from the time fuel is ignited. The rocket has an upward acceleration, so it's only going upward, right? I don't think it's launched at an angle, right? It says it's launched vertically, right? So A at the instant at t equals 0 is equal to 1.50 meters per second squared. And at the instant of ignition, and 1 second later, an upward velocity of 2.0 meters per second. So V at t equals 1 second equals 2.00 meters per second. Determine A and B, including their SI units. At 4 seconds after fuel ignition, what is the acceleration of the rocket? Okay, was that a force or was that V of t? All right. Can I use kinematic equations here?
Yes.
I can? Look at this. Probably not, right? Well, but time squared. So that means acceleration is also changing with time. If you take the derivative, you still have a term for time in the acceleration, right? So that's a no-go right there, right? All right. So we need to find out A and B, and we need to know, what else do we need to know? After 4 seconds, what is the acceleration of the rocket? Any suggestions? Okay, I do know one thing. I know that at t equals 0, I know that acceleration is that. So let's see if we can work with that, okay? So I'm going to take this, and how will I get acceleration from velocity? Just take the derivative, right? Yeah, don't integrate the other way around. Okay, so A equals dv dt equals what? Equals A, right? A plus 2B times T, right? Okay, so I know A at T equals 0 is 1.5 meters per second. My acceleration, not big A. So, if I put T equals 0 here, this term goes away. See that? So if I have A at T equals 0, I solve. I have capital A plus B times 2B times 0 seconds. And that term goes away. And so I know A at T equals 0 is 1.5 meter per second squared. So now I know big A, right? Big A is what? 1.5, right? Everybody see that? So A equals 1.50 meters per second squared. Is that clear? Okay. Clear, Brianna? Good. All right. Now I know this, so I know V of t equals 1.50 meters per second squared times t plus b times t squared. And I know v of t at 1 second. So I'll just write an expression there and see what we come up with. So I have a 2.00 meters per second equals 1.50 meters per second squared times 1 second plus b times 1 second quantity squared. Okay, so it's going to be like 0.50, right, meters per second equals b times 1 second quantity squared, right? So I know this is just 1, right? B is going to be equal to that divided by that. I forgot to do, so B is going to be equal to 0.50 meters per second cubed, right? Second cubed, because I got this squared. Divide this both sides by 1 second quantity squared, and I'm going to get a second cubed in the denominator. Oh, it's a little low for you? Okay. You might want to move up a few seats. Comfortable back there? Okay, it's all right. All right, yeah, so it's second cubed, but we'll put the video online so you can watch it again. Okay, there we go. All right, so we did solve for both components of velocity. All right, any questions so far? Good. All right, I'm going to erase this if I may. All right, so I have v. Now, what do I need to know? I want to know after 4 seconds, at 4 seconds after fuel ignition, what is the acceleration of the rocket? Okay, so A equals A times 2bt, right? Acceleration at t equals 4 seconds equals A, which is 1.50 meters per second squared, plus 2 times 0.50 meters seconds cubed times t, right? Times, what was t, 4 seconds? 4 seconds. And if I could get that value right there, that would be awesome. A at t equals 4 seconds equals, okay, this would be 1 times, times 4, so this term is 4, right? 5.5 meters per second squared. Okay, so that's that one. Everybody good? Can I erase it now? Okay. Okay?
Yeah.
Okay. All right. The next problem says a particle moves with constant speed in a circular path with a radius of 2.06 centimeters. So we've got uniform circular motion. And we've got the radius of 2.06 centimeters. If the particle makes 4 revolutions each second, what is the magnitude of the acceleration? So I guess that's V is 4R, no, 4R, not RPM, right? 4 revs per second. All right. So I have a going around 4 times per second. Okay. Acceleration is going to be, it's a uniform motion. So what is my acceleration? Simply centripetal, right? So according to our definition, a centripetal is v squared over r. Well, I know it's going at 4 revolutions per second, right? Okay. But I need v is, if it's constant, it's delta x over delta t, right? Okay, it's going around that circle 4 times. So I just need to figure out that distance, right? Circumference of a circle. So the circumference is 2 pi r, right? Okay. All right, so we have 2 times pi times, let's convert 0.0206 meters. That's, oh yeah, that's it, 2 pi r. So circumference. Okay, does anybody have that value?
0.129.
0.129 meters. Okay, so V equals 4 times 0.129 meters divided by 4 seconds, right? It's making 4 revolutions per second. So it's doing 4 circumferences. I mean, is it per second or every 4 seconds? If the part makes 4 okay, this is not 4 seconds, that's just 1 second. What is the magnitude of the acceleration? Okay. That's the velocity. Does anybody have that?
0.518.
0. What?
518.
518 meters per second, right? Okay, that's a velocity. And now my centripetal acceleration is simply v squared over r, which would be 0.518 meters per second over r, which is, let's convert, and squared, divided by 0.0206 meters. $13.0 meters per second squared. And that is my centripetal acceleration. Should we turn the camera off? Thank you.